Last but not least, we have a using the identities example, which I said is just basically substitution. So for this one, we have to find all the real solutions of cosine 2x plus sine squared x minus 3 cosine x equals 1. So this is very reminiscent of the double angle formula. And another tip-off that you might want to use that is because this one has 2x in the trig function and all the rest of them just have x. So you want to get rid of that cosine 2x. So that double angle formula has lots of choices. You could really use any of them, but the one I think that will help you the most is if you change it to cosine squared minus sine squared. Because if we make that substitution and write out the rest of the problem, you'll notice that the sine squareds go away. So you're left with cosine squared minus 3 cosine x equals 1. We've got a squared term and then a single term. It's kind of reminiscent of that quadratic equation again, so I think I'm going to bring the 1 to the other side. And from here, we could factor it or use the quadratic formula. So I can't think of anything that multiplies to 1 and adds up to 3, so I think we are stuck using the quadratic formula. So just like above, instead of using, on this one we had 2x equals the answers instead of just x, you're going to have cosine x equals the quadratic formula instead of just x equaling that. So if we do our quadratic formula, that's the opposite of b, so positive 3 plus or minus b squared, so that's negative 3 squared, minus 4 times a, which is 1, times c, which is negative 1. Then all over 2 times a, which we said was 1. And so if we continue this here, that's going to simplify to 3 plus or minus. We're going to have 9 plus a 4. So that's going to be the square root of 13 all over 2. And so if we figure that out as a decimal, that's going to give us, if we do the plus version, it's 3.3028. And if we do the negative version, it's negative 0.3028. So again, those are not nice numbers to make triangles with, or to look at a graph, or to look on the unit circle. So since they are decimals, you're going to have to use your calculator to do inverse cosine. So again, be careful and look in your book and see what mode they want your answers in to know what mode to set your calculator to. So if you do inverse cosine of 3.3028, again, I did radian mode, but since this is bigger than 1, remember the range of the cosine graph only goes from 1 and negative 1. So this one has no solution. So you'll probably get error domain in your calculator when you do the inverse. So when you do the inverse cosine, it has to be a decimal, otherwise it's not going to work. And so if we do inverse cosine of negative 0.3028, I got 1.8784. And I do believe this problem said, yes, to find all the real solutions. So since this is cosine, we're going to have to put a plus 2k pi with that. So there's one answer. The second answer then, cosine is negative. If you think of the unit circle, it's negative in quadrants 2 and 3. And so we would do pi plus, actually if we want to map it out here, so 1.8784 will be somewhere in here. I'm just making up an area here. And so to figure out how far that is from pi, we can do pi minus that, and I got 1.2632. And so if we want to mirror that in quadrant 3, then we would do pi plus that number. So I got 4.4048. So your second answer is 4.4048 plus 2k pi. I suppose another way that you could do that would be, instead of using this angle, use the angle out here, which is your 1.8784, and instead subtract it from 2 pi to get the angle down there. So either way, you will get the same thing.